Hello everyone, I'm very happy to be here with you, even if remotely. In this talk, we'll see how to use some great feature of Postgres as a database in Django. In the database section of the Django documentation, we can read that Django attempts to support as many features as possible on all backends. However, not all database backends are alike. Django per se is a database-agnostic web framework, but unfortunately real-world projects based on it are not. Postgres has the richest feature set of any Django-supported database, and we'll see in this talk how to use some of these superpowers. Before moving on, it's important that I make this clear. Okay, it seems clear to me. Now we can move on. Seriously, I would like to underline that I'm not a database administrator. So, who am I? I'm a Paolo Melchiorre and I'm the CTO of 20Tab, a Pythonic software company for which I work remotely. I'm a software engineer and a long-time Python backend developer. After using Django for a few years, I became a contributor to the project. I also use Postgres as a database for all my Django projects. And I would say it's time to create one. As usual, to create a Django project, I use the latest Python 3 stable, create and activate a virtual env, in which then install the latest stable Django. In this case, Django 3.2.4, released yesterday. Then, using the Django start project command, I create the basic files of our project. And now, let's see what it takes to add Postgres to this newly created project. I think many of you are familiar with this drawing from the Little Prince. This drawing is used as the header of the Twitter account of PsychoPG, a Postgres driver for Python. I think it represents its goal very well, Python with Postgres inside. PsychoPG is the most used and advanced Postgres driver for Python. It implements the Python DB API 2.0 specification and it's distributed under the LGPL license. The library was released 20 years ago and over the time has been constantly improved and kept aligned with Postgres. Version 3 is currently being developed. PsychoPG is a wrapper for libpq, the Postgres C client library. To install this package on a Debian-based system, you can use the apt package manager. For other operating systems, you can read specific instructions in the documentation. For most operating systems, the quickest way to install PsychoPG is using the package available in the Python package index. And now, let's see how to use PsychoPG in Django. To use Postgres as a database in your Django project, we modify the setting, adding this PsychoPG-based database backend and the connection parameters of our Postgres database, which we may have locally or remotely. If you embrace the 12-factor methodology, you can define a database URL variable in your environment. Depending on whatever you use, Django database URL or Django configuration, your database section should look something like this. Let's now see our database in action. We'll use the example model defined in the Making Queries section of the Django documentation. For our test queries, we only use an outer model and an entry model, both containing various types of fields we can search on. We can perform basic queries like these in our models, but actually, we can run these queries using all other supported databases as well. What we are really interested in is using Postgres specific feature from Django. For this same reason, in 1214, Mark Tamlin, a Django core developer, started a crowdfunding campaign to develop a module to contain fields for a number of Postgres specific data types. The campaign was successfully and the new module was merged in Django 1.8. The module now contains Postgres-specific fields, indexes, function, extension, and so on. Over the years, important functions have been added such JSON fields, full-text search, random UUID, and operator classes. JSON fields have become usable also in the other supported database, but only from Django 3.1, released last year, 5 years after being introduced in the Postgres module. To use all the functions of the Postgres module, just add it to the installed apps list in the setting file of our project. And now let's get to know some of the features of this module better. Okay, I took this photo during the sprint day after the DjangoCon Europe 2017 in Florence. And in that day I completed a pull request to add a database function in the Postgres module for Django 2.0. I was helped that day by Mark Tamley, the original creator of the Postgres module, and by Marcus Alterman, a Django core developer, both in this photo. The database function I'm talking about is random UUID. The random UUID database function returns a version 4 UUID. It's contained in the pgcrypto module that provides cryptographic functions for Postgres. It can be activated using the crypto extension migration operation. But from Postgres 13, this function is included in core. To see the function in action, we had a UUID field in our entry model. This field uses Python UUID class, and only when used on Postgres, this stored in a UUID data type. The database will not generate the UUID for you, so it's recommended to use default. But note that the UUID for callable is passed to default, not an instance of it. Using the random UUID function, you can update all UUID value in a model way faster than cycling over all the entries and generating a new value with the Python function. I recently used this technique to set in few seconds UUID in a nearly 1 million row table. Okay, I took this other photo during the sprint day after the EuroPython 2017 in Rimini. I promoted a working group on Django and some developers joined me. That day we started the transition of the Django project website search function from Elasticsearch to a Postgres full-text search solution. Since then I've written an article and give more than one presentation on full-text search with Django, so I skipped the implementation details, but at the end of this talk you will find references to retrieve them. The full-text search support in the Postgres module has specific fields, expression, and function. If your Postgres version is recent enough, you can also use specific indexes, phrase searches, and web search style. Without any customization, we are able to perform a full-text search on a single field of the entry model. For example, we can search for a word in the plural form and have results in the singular form. This is a very convenient way to start using Postgres full-text search out of the box. To speed up the full-text search, we can add a search vector for the entry model and use it to create a functional gene index in the same model. The functional indexes are an addition of Django 3.2, available for all Django database backend, but G-index is only available in the Postgres backend. After that, we can search for a word using a syntax similar to the one used by search engines and have more accurate results. We can use these syntaxes using the search query with the search type attribute. Furthermore, the SQL queries will be faster thanks to the gene index. With this photo, we move virtually in the Northern Europe, more precisely in Norway. I took this photo because I really like the effect of these typical houses in the water, all similar to each other but repeated, like data in an array. The array field makes Postgres array types available in Django. They are very convenient for storing arrays of similar data without creating a new model for them. You can specify other Django model fields as a basis. Its size can be defined, or it can even be multidimensional. For example, we can store multiple emails in our author model by defining an emails array of email fields. We can then query our author looking for an email defined as a list. The content of the field itself is represented as an email list, and the resulting SQL code uses all Postgres-specific operator, like in this example. Unfortunately, the default array field widget in the Django admin is a simple input text with a comma-separated values. But using these Python packages, you can represent in the Django admin the values of the previously specified email fields as a multiple dynamically addable text input. I took this other photo in San Francisco. We are now virtually moving in California because the packages we are going to talk about is provided by the California Civic Data Coalition, an open source network of journalists and computer programmers for news organizations across America. Django PostgreSQL is a Python package to quickly import and export delimited data with Django support for PostgreSQL command. The copy command moves data between tables and standard file system files. Copy to copies the content of tables or the results of a select query to a file. Copy from copies data from a file to a table appending the data to whatever it is in the table already. To more flexibility, Django PostgreSQL uses a temporary table that are automatically dropped at the end of the session. To benchmark PostgreSQL, we'll use a CSV file containing all the geographic names from the OpenStreetMap project. We create a new model that maps each columns contained in the CSV file into a field. We have to replace the model default manager with the one from PostgreSQL. Here we use the CSV file with all the geographical names of Italy. The file is more than 200 megabytes. To upload the CSV file, we use the appropriate query set method in which we indicate the path to the file. The loading speed is impressive, almost 1 million records in just over 3 seconds. Under the hood, Django PostgreSQL executes several SQL statements, creates a temporary table based on the content of this CSV file, upload the content of the CSV file to the temporary table in just over 2 seconds. It inserts the data of the temporary table into the table managed by the featured Django model, eventually applying transformation, and finally deletes the temporary table. To reduce disk space and transmission bandwidth, we have compressed our CSV file in gzip format, reducing the size to a fifth. We can pass our compressed file directly to PostgreSQL without having to decompress it. Loading is even done in a slightly shorter time than measured with the compressed CSV file. I want to repeat it, almost 1 million records in just over 3 seconds. We are now virtually moving in Italy with this photo that I took in a wood in Abruzzo, the region where I live. I'm showing you this photo because now we are going to talk about trees. Django L3 is a tree extension to support hierarchical tree-like data in Django models using the native Postgres extension L3. It's a simpler and faster alternative to implement materialized paths compared to more used Django packages. The package has a path field and an abstract tree model. To add tree-like hierarchy to the entry model, we add a path field inheriting from the tree model provided by Django L3. We also add a dedicated Postgres gist index on the same field to speed up queries. This is a tree representation of the example hierarchical structure that we have stored in the path field of our model. I took this example from the Postgres L3 documentation. We perform a hierarchical query to filter all the contained models of a particular path, sort the result by the tree structure, and then take all the sub-paths. The resulting SQL statement uses the L3 operator to filter the table and the gist index to speed up the operation and the sorting. With this photo, we are now virtually moving on the path of my last hike on the Italian Apennines. I already used this photo in my recent talk about maps with Django, which you can read on my blog, but I want to briefly talk about the geographical extension of Postgres used by GeoDjango. PostGIS is a Postgres extension and it's also the best database backend for GeoDjango. It internally integrates spatial data and has a spatial data types, indexes, and functions. In this chart, I synthesized the compatibility table of the geographic backends supported by GeoDjango. In the GeoDjango documentation, there are three compatibility tables for spatial lookups, database function, and aggregate function. As you can see, PostGIS is the only geographical backend that supports 100% of the feature. If you are interested in using this feature, you can see my previous talk. There are also many other Postgres-specific features that can be used directly in Django. For example, you can use a lot of indexes and aggregation function only available in Postgres. You can also use the trigram extension to perform fast searching for similar string. There are also specific fields only available in Postgres, like range fields and case-insensitive text fields, and more. Before saying goodbye, I want to share with you some tips based on my experience as a Postgres user with Django. Reading the documentation in the Django website is full of information about the Postgres module. Read the details about this feature in the Postgres website. It's help you to understand how things work under the hood. Read the source code of both projects in GitHub because there is something you can learn only from the code. Search also for questions on Stack Overflow, but try to answer questions by yourself instead of reading answer. Last but not least, you can also study this talk because it is released with a Creative Commons license. The PsychoPG3 library is under active development and you can use this contact to learn more about it, get involved and also sponsor its development. The company I work for, 20Tab, is one of the sponsors of this library. In 20Tab we have developed many Django projects using Postgres. You can find more about our open source project and our Platonic works using these contacts. To find out more about my personal work with Django and Postgres, use all my contacts. Using this QR code, you can download this presentation on my website. Thanks again for having me. Enjoy the next talk in the conference. Ciao a tutti.